Unit 2, Lesson 5, Finding Area Under a Normal Model. The lesson is called, Will Marty Make It Back to the Future? This is part 1 of our lesson. All right, please turn to your lesson, and you'll see the first thing we did is we learned in the last lesson is how to label a normal model. So we're going to start with the same thing. We're going to label this normal model here. So we have a mean of 80 and a standard deviation of 7.7. So the way we go about doing that is labeling this 80 and then add 7.7 to receive these values, subtract 7.7 to receive these values. So these are 1, 2, and 3 standard deviations higher and lower than the mean. We're also going to label our curve with the n, the 80, and the 7.7. So making sure that you have all of these things on your normal model. You also are going to label 1 standard deviation to be 68%, 2 standard deviations to be 95%, and 3 standard deviations to be 99.7%. Okay, so the first question said what percent will give the DeLorean a speed of greater than 87.7%? And you can see in mine here, it's that is shaded in green. That's greater than 87.7. Well, if you notice, it sits right at 1 standard deviation, and so remember, 68% is within the curve, so that left on the outside of the curve is going to be 16% on the left and 16% on the right, and so that's how we got 16%. The next one says what percent of the runs will give between 64.6, and 87.7. So you can see, again, this is going to be 95% is here, 2 standard deviations, which is not quite, I don't need quite that, but I do have that this is 68%. So let's go ahead and get this little value here. So this is, the way I'm gonna do this is I want this amount and this amount. So since I know that the bigger one here is 95%, let's subtract 95 minus 68, and I'm going to get, let's see here, wait. Now I lost where I want to track, sorry. All right, so then I'm going to get here, borrow from here, 15 minus 8 is 7, 8 minus 2 is going to give me 27, so that's what both of the circles equal. 27 divided by 2 is going to get me 13.5%, so that's 13.5%, and that's 13.5%. So I want to go from here, so I'm past the 13.5% to here, and then past the 68%. So that's how I get 13.5% plus 68% to get me 81.5%. Okay, what percent will run and give the DeLorean speeds of less than 68.45? Well, you can see here in blue what someone attempted to do is tried to say, well, let's go ahead and look where everything is. So 64.5% is located, or sorry, that's 64.5, 68.45 miles per hour. It's located smack dab in the middle of here. Now, some people said, well, let's get this as 2.5% and then half of this area. But if you can see, let's pretend like this is a cake, right? And it's an oddly shaped cake. And I have piece 1 and piece 2. Which piece would you like? If it doesn't matter because of the same size, you say it doesn't matter. But obviously you can see piece 2 is much bigger. So this is not gonna be correct. So we have to use something, since it doesn't lie perfectly on one of my standard deviations, the way our problems that we've had before just perfectly lied right here on one of these, we're gonna have to use something called our z-score table. So let's go ahead and jump to our z-score table. All right, and so the first, I guess I got just a little bit ahead of myself. Let me try this. The z-score table basically is going to evaluate my scores here, my z-scores, to be able to see, okay, what's the value of my data? The reason I use z-scores, let's just take a small aside, is so that I can compare things on a fair balance. So, for instance, SAT scores, SAT currently is out of 1,600, and ACT scores currently is out of 36, which this is a max score, and this is a max score of 1,636. So this is the problem, is if I say, hey, I got a 1,200 on the SAT and a 34 on the ACT, how do I know which one's better? So that's why we come up with a z-score, and we compare it to its own kind. So the z-score formula is the value that you're given subtracted by the mean, divided by the standard deviation, and that gets you a z-score. Then if I had if I had my SAT z-score and my ACT score, then I could compare and see which one's higher, and I could tell you which one I did better on because it's comparing to itself. So what we're gonna do is our value was 68.45. Our mean that we were given in the very beginning of the problem was 80, and our standard deviation we were given was 7.7. If I do the math, I get negative 1.5. All right, let's jump over to the z-score model now. And I'm going to show you how to do this in here. All right, so this is the z-score model, and we found that our z-score was negative 1.5. So on the z-score table, you can see that there are 2 pages. One has negative values. These are z-scores, which are on, the z-scores are on right here. Let me show you. These are z-scores. Okay, let me explain to you how to read this. So this value, if I were to go here, let's go. And if I said I have a z-score of negative 2.2, then you can see that my z-score of negative 2.2, or excuse me, 2.82, sorry, is this here of 0.0224 is going to respond to that. So this area here, which I'm going to make green, the green area is the percentage under the curve. So for a z-score of negative 2.82, let me just actually draw it up here. So if this is my z-score, I'm going to draw what it would look like. This here, smack in the middle, would be a z-score of 0. And we're going to go 1, 2, 3, 1, 2, 3. So let's look at a z-score of what I just said of negative 2.82. So that's really far out here, right? That's like right here, negative 2.82. And then this area, a z-score, that blue area that I shaded, that is corresponded to this number here, which that's 0.0224, move the decimal over, and it's 0.24%. What I'm saying is if this were the whole graph and this little tiny blue area is the only area that's shaded, 0.24% of the whole graph is shaded, meaning the probability of getting a z-score, the probability of getting a z-score that is less than negative 2.82 is equal to 0.0024. So the probability of getting a z-score that's less than 2.82 is 0.024 or 0.24%, or 0.24% of the graph is shaded. So let me choose a different one, okay? So let me remind you, get rid of this, that the z-scores are going to be highlighted in yellow right up here, and the corresponding percentages are going to be highlighted in green over here. So the green area are the percentages, and the yellow area are the z-scores. Now remember, these are the negative z-scores, but there's also positive ones, but we'll just stay on the negative side for now. The negative side you can see are obviously the biggest number on the negative side you can see is 0. And look at the z-score for 0, 50%. So that literally means this right here means 50% of this guy would be shaded. So all of the z-scores on the negative side, you can see 0 it's less than 0, and that's why they're right here, the negative side. So you can see that less than 50% of the curve is shaded. That's why the biggest z-score on the negative side is 0, and all the other ones are smaller than 50% in the green shaded area. So can you hunt for me for a z-score of negative, let's go with 0.96. So negative 0.96. Now you can find a z-score table, you can Google it. I honestly just Google AP statistics formula chart, and it's the 3rd page, and that's the easiest way to do it. You can Google z-score chart, you can look in the back of your textbook, they're really honestly everywhere. Okay, find the value, the percentages, so I'm looking for the probability that the z-score is less than negative 0.96. So go to negative 0.9 right here. I'm gonna draw it here. And then I need to go to 0.06. So 0.06 is right here. So the value is gonna be 0.1685. 0.1685 in a percentage is move over 2 times, and that's 16.85%. Let's check it on our graph. So if we go up here and check where negative 0.96 is gonna be, it's gonna be a little bit bigger than 1. And here we go. So that means that's about 16% of our area shaded. Okay, let's jump over to our positive side. And it's the same concept. You can see just this time, remember, 0, this is just gonna be 1, 2, 3. And this time you're gonna see that the area is going to be shaded. The smallest one on this side, because it does have 0 on this side, is going to be, because that's half, that's 50%. All right, that's 50% right there. So the smallest one that's shaded is 50% for this one. You can see 50% is the smallest value on this side because it's all the z-scores are positive. So it's asking, remember, this is just asking the area under the curve started from the left because that there is 0, like 0%, sorry. That means 0% is shaded, not a z-score of 0. So same thing, and we just go ahead and highlight this so we can see the z-scores are yellow. And we're gonna do the same thing that the percentages are green. All right, I could make it a little bit quicker, but oh boy, I'm making this kind of a mess. Oh well, I'm having fun doing it. Okay, so if I said, please find me the z-score, or excuse me, please find me the percentage that corresponds to the z-score of, let's just do the probability of the z-score is less than 2.3. So we're gonna go to 2.3. So 2.3 is here. And I said 2.3, so that means that's gonna be 2.30, so 0 is here. And my value is 98.93, 0.9893. So let's go again, 2.3 is about here. So that means all of this is shaded, and that's about 98.93%. Okay, so that's how to do a z-score chart. And our z-score, remember, that we're looking for is actually negative 1.5. So we're gonna have to go back to the negative side. And negative 1.5 is right here. Negative 1.5, and then it's negative 1.50. So that's this area right here. And so that value is actually 0.0668 or 6.68% because I moved the decimal over 2 times. Okay, so that's how to do a z-score chart. Let's jump back to our Marty. Okay, and so that's why we have this as 6.68%, and it says we got from table A. Table A is our z-score chart. Okay, so for this one, number 5 says what percent of the runs will give the DeLorean a speed of less than 68.45. So the first step always, guys, we do want to draw a picture. So let's draw a picture, and in my picture you can see I labeled a couple things. I showed you N8077, that means it's a normal model. That means that 80 is my mean, and that means that 7.7 is my standard deviation. And so I draw a model, put 80, and then I put my value, and I put the percentage, and I even do here, I kind of put question mark percent just to show, or Y percent or X percent or whatever, just show that's what I'm looking for. So then I'm gonna go ahead and find the z-score because 68.45 isn't one of my nice, happy, pretty ones. See, 68.45, which is what we did here. And then we got negative 1.5, and that's how we got the 6.68% because this is just the exact same problem we just did before. This is just making it look a little prettier. Okay, the next one says what percent of the runs will give the DeLorean a speed greater than 85? So you're gonna start with step 1, and you're gonna draw the model, normal model, mean of 80, standard deviation of 7.7. Here's the mean, 85, and this is the area shaded, and that's the percentage I don't know. So I'm putting question mark percentage, and that's what I'm looking for. Because 85 doesn't land happy and easy on my standard deviation, because the first standard deviation, of course, is 87.7, so it doesn't land nicely, I'm going to have to find the z-score. To find the z-score, remember it's observed value minus the mean divided by the standard deviation. I get 0.065. Let's jump back to the z-score table to get 0.65. So 0.65 sorry, let me just mark it up real quick. Okay, so 0.65 is going to be 0.6 is here, and 0.5 is here. So I get 0.7422. 0.7422, and that's going to be, mark up again, and that's going to be my answer here. Oh, no, wait, I got it wrong. But I got the right answer, 0.7422. So that means this is, remember, because it's shaded from the left, is 74.22% is that part. Which when you look at this shading, I looked at it, I said, my goodness, that's not 74% of the model shaded. No, it's the opposite of it. And so it's 1 minus this amount, or 100% minus that amount, and you get the 25.78%. So what percent runs between 70 and 95? So when you draw your model, 70 and 95 are going to be your models here. And you're going to have to do this twice. You're going to have to find the z-score of the first one, because that gives me this area. And then you're going to have to find the z-score of the second one, because that gives me this area. But as you see, I don't want the z-score, I don't want both of them. I don't want this overlapping area. So that's why I'm going to find the z-score of the first one, the z-score of the second one. Look up negative 1.3 in the table, and that's where I'm going to get 0.0968. Look up 1.95 in the table, and that's where I'm going to get 0.9744. And then I'm going to, so first step, find the z-score of the first one, z-score of the second one, look them up in the table. And then the fourth step is I'm going to subtract them, because remember, I don't want this overlap here. I want the green area in the middle. And that's going to get me 87.7%. Okay, I'm going to show you in a second how to do this on the calculator. So first of all, let me show you what it looks like, what the things that you're supposed to be learning from my learning targets, and then I'm going to show you how to do the same thing that we just did on the calculator. Okay, so you can see learning target 1 is area to the left, and it's just the area from the left is the area in the table, the number it gives you. It was very similar to this one here that we did on number 5. The second one we did was the area from the right. And the area from the right was we had to find it. We had to subtract it from 1, because remember the table gives you the area from the left. And finally, the area in between, you have to find the area of each one of them and then subtract the percentage. Okay, I promised to show you how to do this from the calculator. So let me write down the percentages real fast. We have a mean here of 80. We have a standard deviation of 7.7. On number 5, we did less than 68.45. On number 6, we did greater than 85. And number 7, we did between 70 and 95. So let me show you how to do this on the calculator. Okay, so I need you to go ahead. I'm going to bring up my calculator. And I'm going to bring up Normalcdf. Yours is a little bit different than mine, but you're going to hit Menu, Statistics, Distributions, and you're going to go to Normalcdf, which is your second one right there. Okay, Normalcdf allows us to put our bounds in the calculator of exactly what we're showing. So the first one, if you remember, asked me for everything less than 68.45. So let me just jump back to that picture for a reference. So less than 68.45 is right here. This is what I'm looking for. So I need the left, so did you see this here? The options it gives me, lower bound, upper bound are the first two options. Lower bound means how far left is this shaded? Well, this essentially is shaded on the entire model. So I want to make sure the whole model is included. So I usually go with a negative infinity or just negative 9999 because it's easier to put in the calculator. So that's my lower bound. Upper bound is to all the way to the right until it's shaded. Well, it stops being shaded here at this value at 68.45. So that's my upper bound. So that's where my values are coming from. So here we go. So it's already at negative infinity because I have a CAS, but the calculators at the school don't do that. So then I'm going to use 68.45. This little funny symbol is for my mean. It's mu is the symbol. And my mean is 80. And my standard deviation was given to me at 7.7. And that's it. I hit OK. And there's my value, 0.0668. And we got that exact same value. Just to let you know, the values on the calculator are a little bit more accurate, so they're going to be a little different sometimes. But that's OK because we're just looking for the trends of data. Okay, for the second one, let's look at the picture so we have a reference where we're going. The second one, I'm looking for a value, the percentage under the curve that is greater than 85%. So the most left shaded is going to be this value of 85. That's my lower bound. The most right shaded is it goes off the curve, and so essentially we're going to infinity. So I'm just going to put 99. It doesn't matter how many nines. It really doesn't. Just something that's off the curve. My mean and standard deviation are the same. So I'm going to go again with menu, stats. I'll do it for you. Menu, stats, distribution, normal CDF. And my lower bound is going to be, remember, the most left of the curve. This one was 85. The most right of the curve was going all the way off 9, which is 9999. And then the mean is going to be 80, like it was, and the standard deviation is still 7.7. And that gives me 25.81%. And we got from our table something very similar, 25.78%. As I told you, it's not going to be exactly the same, but it's going to be very similar. Okay, for the next one, remember what we did is we found our two z-score values, found the percentage, and subtracted them in between. You're going to really like the calculator on this one because for this one, the most left shaded is right here at 70. And then the most right shaded is right here at 95. So that makes it really easy when you're actually calculating. So we're going to go to menu. I'm going to show you how I got there. Statistics, distributions, normal CDF, and the lower bound is 70 and the upper bound is 95 and the mean is 80 and the standard deviation is 7.7. And I got about 87.73%, and you can see my answer here, which I got 87.76%. So we were very close, and that's fine. Okay, so that's the way you can do it on the calculator. Remember, to get there, I went to menu. This has to be from a calculator page, not from the Scratch, by the way. So go to new document, calculator. Don't do it from the Scratch, from the little Scratch, what is that? The page that's on the main menu. A lot of people use the calculator on that. But go to new document, calculator, menu, and then it's statistics, distribution, and it's normal CDF. Not PDF, CDF. Okay, so that's it for here. Let me go over the answers on this one. All of these are using table A, but I'm going to also just talk through what you would do to get to if you did this on the calculator. So using table A for this first one, go ahead and make sure, if you haven't done this, go ahead and stop it and do the work so you can know how to do it. But for this first one, I came up with the z-score of negative 2.06, looked in the table of negative 2.0, and then, of course, 1, and I went out here to 0.06, boom, 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 and got about this number, 0.0197 is what we got. If you put it into the calculator, you would normal CDF. Your lower bound would be way off here at negative infinity, so negative 9999. Your upper bound is right there at the value you stopped with, which says less than 100 right there. The mean is the mean that it gave us at 151.6, and the standard deviation is 25. Okay, for the next one, the z-score that we got was 1.94. Again, looked it up, and this one we had to do 1 minus it because it gives me this value here, because that percentage is the 97.38% that the chart gives you. So you have to subtract it from that, and you can see the shaded area is closer to 2.6%. If I did it on the calculator, that percent, or that's not what that is, I apologize, but what was it, 200 or higher? Yes, so 200 would be my lower bound. Infinity would be my upper bound. Again, my mean and standard deviation are still 151.6 and 25. And finally, the one in between, if you did it on the chart, you're going to have to find value 1 and look it up and get a percentage. And if you found this percentage, you get 77.04, and then value 2. And then if you look that up, you're going to get 97.38. Then you're going to subtract the difference and get 20.4%. Again, if you did it from a calculator between 170 and 200, you're going to get lower bound for 170, upper bound for 200. Mean and standard deviation are still the same at 151.6 and 100, or excuse me, 151.6 and 25, and you're going to get a very similar answer, about 20%. Okay, thank you for watching. If you would like more demonstrations on the calculator, you can go to my page that is TI Inspire calculator page, and it is also, there's a playlist that has all the different calculator competencies to help you some more. Thank you so much.